In the last lesson, we have learned that evidence comes in shades of gray. The hierarchy of evidence with regard to treatment was like this. The higher up in this hierarchy, the stronger the evidence. But how strong is the strong evidence? Original clinical research studies published in New England Journal of Medicine, JAMA, Lancet, and some other high-impact journals between 1990 and 2003, and cited more than 1,000 times by 2004, were identified. The results of these studies were compared against subsequent studies of comparable or larger sample size and similar or better controlled designs. There were 49 highly cited original clinical research studies, of which 45 claimed that the intervention was effective. They included 2 case series. Well, a little bit surprised that any of these high-impact journals did publish any case series, 4 cohort studies, and 39 RCTs. Of these, 1 cohort study and 10 RCTs remained unchallenged. However, these studies were later contradicted, and these studies were true but later shown to have smaller effect. And only 1 case series study and 19 RCTs were replicated. In other words, none of 4 observational studies and only 19 of 39 RCTs were replicated. True positive rate was 0% for cohort studies and 49% for RCTs. Another group of authors recently examined 12 studies in which claims coming from observational studies were tested in randomized controlled trials. Of the 52 claims made, none was replicated. For 5 of them, the cause-effect relationship was in the opposite direction from those claimed in observational studies. Here is a simulation study of positive predictive value of statistically significant studies. The logic is shown on these slides, and here are the results. For discovery-oriented, exploratory research with massive testing, the positive predictive value is 1 in 1,000, 0.1%. For exploratory observational studies, it is 10 to 20%, and surprisingly enough, underpowered RCTs may have only similar positive predictive values. Collecting these RCTs, PPV may go up to 40%. We need a confirmatory meta-analysis of high-quality RCTs or an adequately powered RCT with little bias to have a positive predictive value above 80%. Of course, these are only simulation results with many assumptions. But if true, we would certainly like to base our clinical decisions on these studies.